Rajasthan, northwestern India. Dry season, 2013. A team of archaeologists is cutting a stepped trench into the sand, 3 meters wide and nearly 4.5 meters deep. All around them, there is nothing but dunes, thorny scrub, and a scorching sky. This is the eastern edge of the Thar Desert, one of the hottest and most lifeless territories on the planet. According to every textbook, this is precisely the place where ancient humans could not possibly have ventured. And yet it is here, layer by layer, that stone tools begin to emerge from the earth. First one, then dozens, then hundreds. When samples were sent for dating, some of them came back with ages approaching 100,000 years. But the strangest part was still to come, because 50 kilometers away, near the salt lake of Didwana, lay another site, excavated 30 years earlier, which, as it turned out, preserved the story of an entirely different human lineage. And when the two stories were placed side by side, it emerged that this very desert may have been the place where two different branches of the genus Homo either narrowly missed each other or, quite possibly, met. For almost the entire 20th century, the model of human dispersal out of Africa into Asia was simple and convenient. Our species left Africa around 60,000 years ago and moved along the southern coast, through Arabia, along the shores of the Indian Ocean, through Southeast Asia, and eventually reached Australia. It was a route of water and fish, a route that did not require crossing inland deserts. And the deserts, stretching in an unbroken belt from the Sahara through Arabia to northwestern India, were considered a wall, not a road. Too dry, too poor in food, too inhospitable for bands of hunter-gatherers to survive there for thousands of years. The Thar Desert, the eastern, farthest edge of this belt, was, in this model, simply a blank spot on the map, the edge of the world where monsoon Asia begins and everything else ends. The first crack in this picture appeared as early as the beginning of the 80s, but almost no one noticed it at the time. In 1981, French archaeologist Catherine Gaillard, together with her Indian colleagues V.N. Misra and S.N. Rajaguru, began excavations near Lake Didwana at a site called Singhi Talav. Over several seasons, they opened up an area of 72 square meters and drove a test pit 4 meters deep, all the way down to the water table. There, in 3 distinct layers, lay dozens of massive stone tools, hand axes and cleavers, worked on both sides, heavy and crude in appearance. This was the Acheulean culture, the oldest known tradition of deliberate toolmaking, a culture associated not with modern humans, but with far more ancient and archaic members of the genus Homo. Direct dating methods capable of yielding a precise age did not yet exist at the time, but based on indirect geological indicators alone, the researchers suggested that they were looking at one of the oldest Acheulean sites in India, possibly older than 390,000 years. The picture fit exactly what everyone expected to see. Somewhere in the unimaginable depths of time, very ancient, very primitive people had lived here, and then the desert had lain empty for hundreds of thousands of years, until, much later, modern humans crossed it along their usual coastal route. It took nearly 40 years for this tidy story to fall apart. In 2021, an international team led by James Blinkhorn, by then working at the Max Planck Institute for the Science of Human History, together with Hema Akuthan and Julie Durkin of Oxford, returned to Singhi Talav. This time they had methods that had not existed in the 80s, luminescence dating, which makes it possible to determine when quartz and feldspar grains in sediment layers last saw sunlight. The method yielded direct, independent dates for each horizon, and the result turned out to be the complete opposite of what had been assumed 40 years earlier. The main, most artifact-rich layer belonged not to remote antiquity, but to an age of roughly 177,000 years. Other horizons dated to around 248,000, 85,000, and 65,000 years. The site, once considered one of the oldest Acheulean settlements in India, turned out to be one of the youngest Acheulean sites on the entire planet. And this is where the truly strange part of the story begins. The point is that by the time hand axes were still being made at Singi Talav, this technology had long since vanished almost everywhere along the presumed route of human dispersal. In East Africa, the Acheulean tradition faded away approximately 214,000 years ago. In Arabia, around 190,000 years ago. And yet in the Thar Desert, people who clung to this same technology, obsolete everywhere else, kept returning to the shores of the ancient lake for at least another 177,000 years, tens of thousands of years later than their technological relatives anywhere else in the world. This was not simply an ancient site. This was a relict, isolated population that had lingered in this desert refuge longer than any other bearers of this tradition in the world, and vanished from the record we can read only shortly before an entirely different kind of human, apparently, was due to appear in the same region. Because just over the ridge from Singi Talav, along the same system of ancient water bodies, lies the site of Katawati, the very trench with which this story began. The excavations there, between 2010 and 2013, were led by that same James Blinkhorn, then working at the University of Bordeaux, together with Hema Akuthan, Michael Petraglia, and Peter Ditchfield. But the tools they found had nothing in common with the crude hand axes of Singi Talav. Here was Levallois technology, a method in which the toolmaker first carefully prepares a stone core and then, with a single precise strike, detaches a ready, almost symmetrical blank for a knife or a point. This is an entirely different level of planning, a different, more sophisticated culture of the Middle Paleolithic. Using micromorphological analysis of the sediments, measurements of stable isotopes, magnetic susceptibility, and X-ray fluorescence analysis, the team reconstructed the very appearance of the landscape itself. At the time these layers were forming, rivers ran through the desert, and sorghum-like grasses and amaranth grew where the desert stands today. In other words, there was no desert here at all back then. The lower, securely dated horizon lay at around 96,000 years. At the time of publication, this was the earliest, securely dated Middle Paleolithic site in all of South Asia. The second horizon dated to around 60,000 years ago, precisely the period when, according to genetic estimates, modern humans are thought to have begun spreading across South Asia. And nearby, on a dune overlooking Lake Didwana itself, back in the 80s, Misra and Rajaguru had excavated a third site, 16R Dune, where a similar Middle Paleolithic technology was dated in the range of 80 to 40,000 years, with less distinct but still detectable traces reaching depths that hint at nearly 180,000 years. In other words, within the bounds of one small desert basin, two entirely different storylines turned out to be woven together. One, a fading, archaic tradition whose last bearers still roamed here 177,000 years ago. The other, a new, more sophisticated technology that appeared in the same place tens of thousands of years later, and was, quite possibly, brought by an entirely different species. The researchers who published the Singi Talav data phrased it with maximum caution. The Thar Desert may have been not simply a corridor of dispersal, but a genuine demographic and behavioral frontier, a zone where Homo sapiens may have encountered another, closely related but distinct human population. This alone overturns the old desert as insurmountable wall model. The work of Blinkhorn and his colleagues points directly to it. The route of human dispersal from Africa into Asia is traditionally drawn on maps as a coastal corridor that skirts the deserts. But field data from the Sahara, from Arabia, and now from the Thar show that during the humid phases of the Pleistocene, when the monsoon strengthened, rivers filled, and grass appeared along the shores of lakes, these same deserts turned into perfectly passable, even hospitable continental corridors. Confirmation of this came from a discovery at the Nal Quarry, in the very heart of the Thar Desert. There, for the first time, traces of river activity from the Middle and Late Pleistocene were directly dated, proof that rivers really did flow where today there is nothing but dry sand. And in the sedimentary layers of the same region, researchers discovered ostrich eggshell, a bird that lives nowhere except Africa and its neighboring territories. These finds not only helped refine the dates through radiocarbon analysis, but also showed that during the humid periods, it was not only groups of people who advanced into India, but entire ecosystems that followed them. There is also another coincidence, too striking to ignore. About 74,000 years ago, on the island of Sumatra, one of the largest eruptions in Earth's history took place, the eruption of the Toba volcano. For a long time, it was believed that it caused a multi-year volcanic winter and nearly wiped out early human populations across the globe, the so-called Toba catastrophe. It is precisely this interval that falls into the gap between the two horizons of Katawati, the 96,000-year and the 60,000-year layers. And more than 700 kilometers to the south, at the site of Jwalapuram in the state of Andhra Pradesh, a team led by Michael Petraglia and Ravi Korasetar discovered Middle Paleolithic tools directly above and below a layer of volcanic ash, practically identical in style before and after the eruption. A similar picture of continuity was later confirmed at the site of Daba in the state of Madhya Pradesh, where one and the same tool tradition can be traced across roughly 15,000 years, including the moment of the eruption itself. If the same is true for the Thar Desert, it turns out that the people who left the tools at Katawati may have survived one of the largest geological catastrophes in the history of the planet, without so much as interrupting their customary way of working stone. But the most unsettling addition to this picture came not from the Thar Desert, but from the coast of Tamil Nadu, 1,500 kilometers to the south, and it calls into question no longer merely the survival, but the very origin of this whole technology. At the site of Adirampakkam, a team led by Shanti Papu and Kumar Akhilesh, who published their results in the journal Nature in January 2018, applied dating based on the accumulation of cosmogenic nuclides in quartz, a method independent of both luminescence and radiocarbon, and obtained ages ranging from 385,000 to 172,000 years for tools made in a technique very similar to Levallois. 385,000 years ago is noticeably earlier than the point at which, by most estimates, Homo sapiens as a distinct species had even had time to emerge. The authors, tellingly, were extremely cautious in their wording. Not a single human bone, not a single tooth, was found at the site, which means that, in their own words, it is impossible to determine which species this technology belonged to. And this is where the main, still unresolved problem of the entire story is laid bare. Neither at Singhi Talav, nor at Katawati, nor at 16 Ardun, nor at Adirampakkam, nowhere in the entire record of the Middle Paleolithic and Late Acheulean of India has a single human bone ever been found. All conclusions about who exactly held these stones in their hands rest solely on the shape of the stones themselves. And shape, as it turns out, is an unreliable witness. Paleoanthropologist Parth Chauhan has drawn attention to the fact that Levallois technology is more likely to belong to archaic hominins. The Neanderthals of Europe and the Near East developed a nearly identical prepared core technique, entirely independently, without any contact with modern humans. The geneticist Mark Stoneking of the Max Planck Institute has spoken even more cautiously, noting that on the basis of tools alone, it is simply impossible to tell who made them, Homo sapiens or some archaic relative of ours that we have yet to discover. In other words, the similarity of stone tools may signify the migration of people, or it may signify only that different, entirely unrelated lineages of the genus Homo again and again arrived at the same technical solution when confronted with the same problem. So who, then, left the tools in the sands of Katawati, the first waves of our own species, passing through a desert temporarily turned green, or archaic relatives of ours, independently arriving at the same prepared core technology? And did any of them meet the last bearers of the Acheulean tradition, still wandering the shores of Lake Didwana 177,000 years ago? The honest answer today sounds the same as it does in all such stories. We do not know for certain. The desert has no witnesses ready to speak, only stone, and stone is silent about whose hands once held it. The Thar Desert looks as though nothing had ever happened in it. The same dunes, the same dry, motionless line of the horizon, where time itself seems to have stopped long before humans ever appeared. It was precisely this visible emptiness that for centuries convinced researchers there was nothing here to look for. But beneath the layer of sand that no one had bothered to redate a second time, two human stories turned out to be woven in, one fading, the other only just beginning, and between them lies a gap that science is not yet able to close. Perhaps the answer waits in the next meter of sediment, still untouched by a shovel. Or perhaps it is already lying in a museum drawer, among stones dated just once, 30 years ago. If you find stories interesting about discoveries that force textbooks to be rewritten, subscribe and stay with the channel. We are only just beginning to dig.